Hi my students, today we will solve the homework and we will complete our lesson. The first one, sodium bromide. Again, you must write the samples of each element and you must memorize it, by the way. Sodium is Na, bromide is Br. This is the first step. The second step, write the valency of every element, or I mean the charge of every element. Sodium is in group number 1, and according to our table, we said that the valency of the elements that are in group number 1 equals 1. So this is 1, and because it is a metal, so it is carrying a positive charge. Bromide is an element from group 7, and I told you that the valency of the elements that are in group number 7 is -1. Or you can solve it by another way. You can say that the elements that are found in group number 7 has 7 electrons in their outer shell. But how many electrons do they need to be 8? Actually, they must gain 1 electron. So the valency of the elements that are in group number 7 is -1. Is -1. Negative means gain, and 1 because they will gain 1 electrons to be 8 according to the octet rule. Again, what is the octet rule? This rule says that any element, metal or non-metal, wants to look like the noble gas, the arrangement of the noble gas, by gaining or losing electrons. Type. Then 1 with 1 they will cancel each other, so it will be NaBr. Boron oxide. Boron is in group number 3. Again, this is boron. It is in group number 3, so the valency is +3, as I told you. Again, 1, 2, 3, 3, 2, 1. So the valency here is +3. So boron is B, +3. Oxide is O, -2. I cannot cancel them. They will not cancel each other like in the first example. So just switch them to be B2O3. Question number 3, aluminum iodide. Aluminum is in group number 3. Iodide number 7. 7 means -1. 3 +3. Cross them. We will get Li3. Potassium oxide, KO. -2 +1. K2O. Calcium oxide. Calcium is in group number 2, so the valency is +2. Nitride means nitrogen. Nitrogen is in group number 5, so the valency is -3. You must memorize them. These valencies are found in the table. So it will be Ca3 N2. So Ca3 N2. Lithium sulfide. Lithium Li, sulfide S, +1, -2. But all of them here, the cross multiplication, and here also. So we will get Li 2S, and that's it. Now we will explain more examples. Okay. Iron 3 oxide. This 3 means the oxidation number of iron. So, as you know that iron is a transition element. And we said that the transition elements in general have more than one valency. These elements do not have a specific charge or a specific number. Like group number 1, for example, their valency is always positive 1. Anywhere, any example, any compound, group number 1, its valency is positive 1. Group number 2, for example, its valency is positive 2. But the transition elements, they have more than one charge. So they have more than one valency. But how can I know which valency do I mean here? So I must give you the number or the charges of the previous element or of the transition metal. So if I say iron is 3, this means that you must write, iron is Fe, you must memorize it. 3 means put 3 here. Because it's a metal, so it should be positive. This means that here it's much easier than guessing the valences in the previous example. So actually this case this case is much easier. Why is much easier? Because I'm writing the valency of the element that I want. So the only thing that you have to do it is to write the sample of the metal, which is iron, which is here in this case Fe, and write the valency, which is positive 3. Oxide is O. Oxygen is in group number 6, so it must be minus 2. Cross multiplication, or just switch them. So we will get Fe 2O3. Fe2O3. Example number 2. Iron 2 oxide. Look, in this case, the valency of iron is 2. But in the first question, the valency of iron is 3. Actually, iron has 5 valences, starting from 1 and ending with 5. It has 5 valences. Iron 1, iron 2, 3, 4, 5. Again, how can I know? I must write it for you. Iron 2 oxide. So here I'm telling you that the valency of the iron that I want is positive 2. Oxide O minus 2. Why oxygen minus 2? Because it is in group number 6. And I told you that group number 6 has 6 electrons in the outer shell. This means that I need 2 more electrons to reach 8. 2 more means minus 2. Minus means gain. So, okay, I will write Fe2O2, but is this the final case or the final answer? No. Is this formula acceptable? No. Actually, you must write it using the simplest form. The simplest form means cross it and write it like this. Fe1O1, but not necessary to write 1, so FeO. So you must write the numbers using the simplest formula. Or you must write the formula using the simplest numbers. Okay. Copper 2 oxide. Now, the valency of copper is 2. So again, Cu, chloride, Cl, here is positive 2, chloride minus 1, just switch them. So Cu, Cl2, as simple as that. Copper 1 chloride, Copper is Cu, chloride Cl, 1 means positive 1, chloride means chlorine, which is in group number 7, so the valency is -1. 1 with 1 cancel each other, so it is CuCl. Carbon dioxide. Di means 2, as I told you from grade 7. Di means 2. So, carbon is C. Dioxide means 2. But if you want to obey the valency rules here, you will write that the valency of the carbon is 4. Whatever is the charge, positive or negative, here we don't care about that. I'm caring about the number, by the way. And oxygen is 2. Here minus, so here it must be, or I can't write positive. Here is the type of the charge or the type of the bond is a covalent bond. What does this mean? Not necessary to do that or to know that. So, enough to know that it is 4. Cross it. So it is C2O4. So again, carbon dioxide, carbon is 4 and oxygen is 2. Here, not necessary to know what is the charge exactly, because as I told you, this is a covalent bond. So it's a sharing. It's not positive or negative, but not necessary to know that actually in the details. Cross it, it is C2O4. But I cannot write it like that. I must write it using the simplest formula. So the simplest formula is C1O2. It is carbon dioxide, CO2. Type. Can I solve it using another method? Yes. Simply, di means 2. So, 2 oxygen. So write 1 carbon and 2 oxygen. That's it. طب carbon monoxide, mono means 1. So O1. Carbon, 1 single carbon, 1. So C1O1. طب sulfur dioxide, again. Sulfur is di. Oxide, di means 2. SO2. طيب. In general, if the formula containing these Roman numbers, mono, di, tri, don't do the valency rules. I mean, not necessary to write the charge of everyone and cross them and do that whole story. Enough to know that these numbers describing the number of the atoms that must be written. So, simply write them directly. Sulfur is di 2, so SO2. That's it. Sulfur trioxide, for example. Tri means 3. Tri means 3. So SO3. That's it. Do not do the valency rules and the cross multiplication and that long story here. طب silicon tetrachloride. Silicon Si. Chloride Cl. Tetra 4. Hi 4. That's it. So, don't obey the valency rules if you have these Roman numbers. Just write them directly without doing any calculations. طب nitrogen oxide or nitrogen monoxide. Sometimes we write nitrogen oxide without writing the number of the atoms, because if they are 1, we don't need to write mono, but sometimes they wrote it. So nitrogen monoxide or nitrogen oxide, it's the same. Nitrogen N, mono 1, so it is NO. That's it. My dear students, you must memorize these numbers, and I gave them to you on grade 7, by the way, in grade 7. Mono means 1 in lesson 2.4 or 2.3, sorry. So, lesson 2.3 in grade 7, we took this note, and here we are repeating it. Mono means 1, di, 2, tri, 3, tetra, 4, penta, 5, hexa, 6, hepta, 7, and octa, 8. So if I write silicon trioxide, SiO3. طب تيترا O4, SiO4. طب penta, SiO5. Of course, we don't have this number, we don't have these compounds, but يعني imagine that we have silicon hexaoxide, SiO6 type. These numbers actually are very useful in writing the organic compound in grade 10. So, enough to know them. And later on, inshallah, we will write them in more details. In grade 5, in grade 8, enough to know till 4. From mono till tetra. But these numbers, penta, hexa, hepta, octa, describing the number of the atoms in the organic compounds, you will take them later on. Memorize the names of the common acids. Also, we have taken them in the first term: sulfuric acid, H2SO4, carbonic H2CO3, nitric acid HNO3, hydrochloric acid HCl, phosphoric acid H3PO4. You must memorize them. How can I ask you about this in the test? Simply, I can say octa means 8, 7, 6, like this, a multiple choice. You will write or you will choose 8. So, I will not ask you to write the formula of the compound that has 8 carbon atoms or 8 oxygen atoms because it has another rule, but enough to memorize the numbers in this grade. And if I want to ask you about anything, I will ask you like this: mono, di, tri, tetra, not more than this, by the way.